the first part of graphical methods, we'll be looking at parabolas. Now, parabolas in general are in the form y equals x squared. If you're not sure what a parabola looks like, the best thing to do is make a table of values. Now, for a table of values, let's pick some values close to 0, so maybe negative 3 through 3 for x, and then we'll get the y values. Now remember, when we square a negative number, we have to put it in brackets, otherwise it won't give us the right answer on the calculator, because negative 3 times negative 3 is positive 9. Without the brackets, it would just be like 3 squared and leave it negative. So we want positive 9, negative 2 squared is 4, negative 1 squared is 1, and 0 squared is 0, of course. 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now remember, what we've just found are coordinates. So if I list the x, y coordinates, I'm just listing the two answers, but in coordinate form. So let's put these coordinates onto the grid. And we'll start at the origin, so the 0, 0 point. We'll put that one on first. Then I'll put on 1, 1, 2, 4, and 3, 9. I'll kind of approximate where I think 9 is about. And then we'll do the negative coordinates. So on the other side, we'll have negative 1, 1, so to the left 1 and up 1, negative 2, 4, and negative 3, 9. And then we'll draw the parabola on, connecting up those points. So it would look something like that. So let's talk about the parabola in general if we were actually going to modify it, so how we change the shape of it. So we would get y equals a bracket x minus b squared plus c. So first, we'll talk about a. Now a controls the shape of the parabola. So that means whether or not it's skinnier or fatter than the standard y equals x squared parabola. So if we increase the value, so normally if there's nothing there, it's like a 1. So if I was to put a 4, for example, y equals 4x squared, that's going to make it skinnier. For every y value, it now gets multiplied by 4. And if I was to put a value less than 1, a fraction, like 1/4 x squared, that makes it wider. The other thing that can happen with a is if we have a negative value. So y equals negative x squared would flip the parabola upside down. B controls the horizontal shift, so that means left and right. Now the interesting thing with B is that it actually moves opposite to how you think it would. So normally you would think as negative being to the left and positive being to the right. But in these formulas with the graphs, the minus b actually moves it to the right, and a plus b would move it to the left. Now on a standard parabola, y equals x squared, the turning point, also known as the vertex, is situated at the origin, 0, 0. So that means at the intersection of the x and y axes. So if you think about the part of the equation that's in the brackets, usually x minus b, what you really want to think about is what would you put in for x to make that equal to 0? Because normally 0 squared is 0. So if you had something like x minus 1 in that part, what would you need to put in to x to make that all equal to 0? And the answer is positive 1. Positive 1 minus 1 would equal 0. So therefore, In that part of the equation, the reason it shifts the opposite way is because it's what x value would go in with the b to actually get 0. So in the equation we normally just look at the b, but it's actually the x that's going in to balance it out to 0. That's where the vertex is, and that's why it shifts opposite to what you think it would. Now C controls the vertical shift. So that's the up and down, and that's just like normal. So up is positive and down is negative. Now let's do an example. So we can sketch and describe based on our general parabola y equals x squared and talk about how it's moved. So for our first one, y equals 3x squared. Remember that's a, so that means that it is 3 times skinnier than our standard parabola. Y equals x plus 4 squared. That has been shifted. Now, do you remember which way? Left or right? Remember it's opposite, so plus actually moves it to the left. So this time it would be a shift to the left 4. And we call a shift a translation. So you can say it was translated to, or a translation to the left 4. For our next example, we'll do y equals x squared minus 5. Now remember C moves it up or down, so that's a translation down 5. And for another one, let's do y equals negative bracket x plus 3 squared plus 1. So remember, the negative means it's upside down. The plus 3 is a translation to the left 3, and the plus 1 at the end is up 1. For our next one, let's talk about modeling. So using 2 points and fitting a curve to those. So for example, let's do 1, 2 to 5, 7. Now since we'd have to find letters A, B, and C to model this, the best thing to do is to pick one of them to be the reference point. If we pick it to be the vertex, then we are setting up to find B and C, and then we only need to find A. So this first one that we have kind of looks like a ramp, and that could be either direction. If it's upside down, it looks more like a hill. So the hill could go either way. So which one would you set to be the vertex? Now we're going to pick 1, 2. Why are we going to pick that? Well, if I look at it and I draw the other half of it, we can see that that is the bottom of the parabola. So our vertex, in this case, is BC. So the vertex, as a reference, is a translation to the right 1 and up 2. Remember, the standard parabola is at 0, 0, the vertex. So therefore, we know B is 1 and C is 2. So subbing that in, y equals a, x minus 1, and remember it's minus in the formula, squared, plus 2. Now in order to solve this, we want to set it equal to the other point. So we're going to sub in the other point. That'll force it to go through that. And remember, coordinates are always x first, then y. So our equation is y equals, so it's that second value comes first. So 7 equals a bracket 5 minus 1 squared plus 2. So the first thing I would do is move the 2 over. So 7 minus 2 is 5 equals 5 minus 1 is 4, and 4 squared is 16. So 16a. And then the last step would be to divide by 16. So a equals 5 over 16. Then all we need to do is sub that back into the original equation. So therefore, y is equal to 5 over 16 bracket x minus 1 squared plus 2. The other thing we can list here is the domain. Remember, it only goes between 2 different x values. We don't want the whole parabola, we only want part of it. And it was going between 1 and 5. So x is greater than or equal to 1 or less than or equal to 5. So that makes it go between 1 and 5. Let's try another parabola where we're modeling. So for our second example, we'll go between 2 new points, and I'll just make them up. So this one, I'll do the other way. It looks more like a hill. And just as a side note, the other thing we can call this, and another way to call them, so if it's a regular parabola, it's called concave up. So the concave part of it is facing upwards. That means that the vertex is a minimum. If it's the other way around, it kind of looks like a hill, then it's called concave down. And that makes the vertex a maximum. So our first one is kind of like the ramp, and the second one is a hill. And the first one looks a lot like a half pipe, really, like a skateboarding ramp. So back to our example, we've got a hill. So let's just make up some points here. -3, 2, and 4, -3. Now which one do you want to be the reference point? The first one or the second one? It's the first one this time. Because if I was to think about what the other side of it would look like, it would go from there. So it's an upside down parabola. It looks like a hill. Think, if it went the other way, if I picked 4, -3 to be the reference, that would make it look more like a ramp, and that would be the wrong curve. So I need to make the top one my reference point. So if the top one is the vertex, that is telling us that that is the shift. So if we let -3, 2 be the vertex, therefore that's a translation left 3 and up 2. So therefore B is -3 and C would equal 2. So if we sub those into our equation, we get y equals a bracket x minus -3. Remember, it's already negative in the formula, so we have to sub in -3 into it, squared plus 2. And remember, a minus and a minus is a plus. So we get y equals a bracket x plus 3 bracket squared plus 2. So we do the same thing we did last time. We're going to sub in the other point to make the curve go through it. So we're going to sub in 4, -3. And remember, -3 comes first because that's the y. So y. So -3 equals a bracket 4 plus 3 squared in brackets plus 2. So I'll move that 2 to the other side, minusing it, so that becomes -5 equals, and 4 plus 3 is 7, and 7 squared is 49, so 49a. Divide by 49 to get a by itself, so -5 over 49. And then once again we sub that into our equation, so finally write it, y equals -5 over 49 bracket x plus 3 bracket squared plus 2. And this time our domain goes between, we can go back up and check. Let's take a look here. It goes between -3 to +4 for the x values. So that's what we're going to put as our domain. So x is greater than and equal to -3 and less than or equal to 4. And if you notice, the arrows always go the same way, and you always go from left to right. So the smallest value on the left, biggest value on the right. Hopefully you found that helpful to do some questions on parabolas.